Okay, welcome to the first of many installments of the Algebra Review Study Guide for the Milestones, okay? I'm just going to go through this question by question. I'm going to give you a little bit of back knowledge, or I'll explain a little bit about each question. And since there's so many, I can't spend too much time on each one, so I'll do my best. We are going to select all of the following equations that represent a non-linear function. So you are going to have questions on the milestone in which there's more than one answer. And it's harder because the opportunities to miss increase. So if you said that there's 3 correct answers here and there's only 2, I mean, there's more ways to get it wrong. So because if you leave something out, it's incorrect as well. You have to remember with nonlinear functions, nonlinear functions either have an exponent or a square root. They have variables touching each other. You have variables in the bottom of a fraction, okay? I do not see any variables in the bottom of the fraction. This fraction right here, this says 3/4 x. That is absolutely fine. This x is actually in the numerator, which is in the top. So we're not going to select that one. B has an exponent. We're going to circle that one. C, I don't see an exponent. Don't see a square root. Don't see a variable in the bottom of a fraction. Don't see variables touching each other. That one's going to be linear as well. And the other one that is non-linear will be D, because you have 2 variables touching each other, okay? To get this y by itself, you'd have to divide both sides by x, and then you'd have a variable in the bottom of the fraction. Okay, moving on. So there's, like, guys, these questions you can't afford to get wrong, all right? There's, like, no math involved. You're just looking at it. There's no computation involved, all right? You're just looking at it and determining if it's linear, all right? If it has a constant rate of change. And for equations, that's just a little bit of memorization on your behalf, all right? Question number 2, this one gets very tricky. This is a tough question right here. Fill in the numbers for the table that would make the table represent a linear function. Well, if it's linear, like we just said, it has to have a constant rate of change. So we are going to assume that it is linear, and we're going to fill in the numbers right there that would make it linear. So the only way we could go about doing this is we need to figure out, so if it is linear, it's going to be in the form y equals mx plus b, as I'm sure you have heard that many of times by now. Your input is your x, that's these numbers up here. Your output is your y, that's the numbers down here. The m value is your slope, or the rate of change, or the steepness. And the b is going to be where it crosses the y-axis, like where it is in the graph, okay, its position. We have a bunch of x's and y's, so we can plug numbers in for x and y, that's no problem, but we need to figure out what m is, we need to figure out what b is in order to figure out what this missing number is, okay? The first missing number of this gap right here. So in order to find the m value, we're going to do the rate of change. Well, the only 2 ordered pairs that we are given are these 2 ordered pairs right here. So we're going to figure out the rate of change, that's the change in y or the change in x. How are you going from -7 to -3? You are not getting bigger. Or you're not getting smaller, you're actually getting bigger, because from -7 to -3, that's increasing. Think about a number line, all right? You're going to the right. So you are increasing by 4. All right, from -7 to -3 is not -4, you're going up by 4. And then from -4 to -2, in the same token, you're going up by 2 because you're getting larger. Would you rather have -$4 or -$2? So that leaves us with 2 over 4 or 4 over 2. It's the change in y divided by the change in x. So what I'm going to do now is, we know that the m value is 4 over 2, which is just 2. We now got to figure out what the b value is. So if our m value is 2, we're just going to pick one of these ordered pairs. It doesn't matter. We have -4, -7. So let me erase this. You have -4, -7 as one of your ordered pairs, and you also have. Hold on.
Daddy.
Yes.
I'm going to.
Okay. All right. All right. -4 to or you have -4, -7, and then you have -2, -3. It doesn't matter which ordered pairs you choose. I'm just going to choose this one, -2, -3, because it looks like the numbers are a little bit easier. X is -2, so I'm going to put -2 in for x. It says y is -3. I'm going to put -3 in for y. And now we solve for b. So now we have an equation with just one variable that we're trying to solve. So this right here, 2 times negative 2 is negative 4. So you would say negative 3 equals negative 4 plus b. And to get the b by itself, if you wanted to, you do your boxes. I have a negative 3, and then I add 4 to this side, because when you change the side, you change the sign. And you have your b in this box right here. So you are left with b equals negative 3 plus 4 is 1. So our b value is 1. Well, now we know our equation is y equals 2x plus 1. Now, how is that going to help us here? Well, to get this value, to get our x value right here, what we're looking for, we're going to solve for x knowing that y is 1. So we're going to put a 1 in for y, and we're going to say equals 2x plus 1. So we're going to do our boxes here. You get this 1 comes right down in here. This 1 comes over here. You change side, change sign. It's going to be 1 minus 1, which is 0. And then 2x equals 0. Your x value is 0. X equals 0. So I'm going to put a 0 right here. A lot of work to get that one little number right there. All right, I get it. I understand. We're not going to give up, though. You're going to have some questions like this that are going to take a little bit of time. All right, just skip and come back to them if it's taking you too much time. All right, so we got a 0 right here. All right, now, since we're going from 0 to 3, we got to figure out what this number is here. So it kicked me off. It kicked me off there. Determined the equation was y equals 2x plus 1 by figuring out what the b value was, given that the m value is the rate of change. So what we're going to do now is we're going to figure out what this y value is, given that x is 3. So we're going to figure out what y is when x is 3. 2 times 3 gives you 6. 6 plus 1 would give you 7. So, guys, that question took about 5 minutes to answer. I wanted just to thoroughly explain it. It's not the answer that's important. It's the logic and how we went about getting the answer that's important. All right, the process is more important than the product. We can squeeze in this question here. What are 2 ways in which we can identify the table below as being linear? All right, linear means a straight line, yes. It also means a constant rate of change. So, with those 2 things, straight line. With these response questions in which you've got to answer in sentence form, I would write, the first way I would identify the table below as being linear is by plotting the points on the coordinate plane and seeing if they form a straight line. If that takes you too long, it shouldn't take you too long to just jot down or type in that sentence that I just said. You don't want to take too long, but also you want to be as thorough and explain it as much as possible, because they don't know that you know what you're talking about. They're going to assume that you don't. It's your job to prove them wrong, okay? So you could plot the points on a graph to see if they form a straight line, and also constant rate of change. Do you have a constant rate of change in this table? Well, we got to look. From negative 9 to negative 5, you're going up by 4. Negative 1 to 0, you're going up by 1. So that is a change of 4 over 1. Negative 5 to negative 1, change of 4. 0 to 1, up by 1. Now, let's look at negative 1 to 7. That's where it gets a little bit interesting. That's where kids think that this is nonlinear, because they say, oh, well, we're not, that's not going up by 4. Well, the x's are going up by 2. The y is going up from negative 1 to 0 is 1 time, and then from 0 to 7, that's another 7 times. So to go from negative 1 all the way to 7, that is a total of 8 times. And 8 over 2 simplifies down to 4. So the 2 ways you could identify that as being linear is plot them, see if they form a straight line, and then do the rate of change, see if there's a constant rate of change. Look at the next questions in the next section. Later. Right, so we're on question number 4. I'm going to be going through some of these a lot quicker than I will the other ones. Like question number 2 took up a long time. So like question number 4, which of them represents a linear function? The key word here is function, all right, because there's 2 that are linear, all right? You know that linear means a straight line has a constant rate of change. It's either C or D, because those are both straight lines, but which one of them is a function? D is not a function because it does not pass the vertical line test. It is not a function if there is more than one y for a value of x. So that ordered pair right there could be negative 4, 0. And this ordered pair right here, this one right here could be negative 4, 0. This ordered pair could be negative 4, positive 3. So you'd have 2 values of x that have the same y, or 2 values of x that have different y's, so that's not a function. This is the only one that's a linear function to be c. All right, moving on. Trinity is sketching. All right, so your answers might vary here. It says Trinity is sketching a graph. Oh, where'd you go? Trinity is sketching a graph of the relationship between inches and feet. After she made a table of values, she plotted the ordered pairs to create this graph seen below. And you have that graph right there between inches and feet. It says create a table of values that represents the relationship between feet, which is x, and the inches, which is y. That represents Trinity's graph. So you're looking up the graph, you're making a table. That's all you're doing here. All right, you're looking up at the graph and you're making the table. Then create a table that Trinity should have used. That is implying that this table is wrong, or that this graph is wrong. Like she did something wrong in this graph. Like when she was doing inches and feet, she did something wrong. So your first ordered pair for Trinity's table, if you notice, what she did wrong here is she started on the y-axis at 12. You can't start here at 12. This has to be 0. Like this bottom line here has to be, it's got, like this is starting at 0. And then this could be, like the next line up could be 12 and this could be 24. All right, it's fine that you're going by 12s. You just can't start at 0 and say that that's 12. So her ordered pairs are 1, that would be 0, 12. This is a 0 right here. All right, that's a 0. So that would be 0, 12, and then you'd have 1, 24, and then you'd have 2, 36, and then you'd have 3, 48, and you have 4, 60. What she should have done is she should have put, you start at 0, 0. Guys, if you have 0 inches, then you have 0 feet, and vice versa. All right? So 0, 0, and then you have 1, 12. There are 12 inches in 1 foot. That means that there's 24 inches in 2 feet, and so on and so forth. All right? So that's what she did wrong there. No offense, Trinity. I wouldn't say you did anything wrong, but all right. So part B. This is a constructed response question, all right? So it says, write the linear equation based on the information from the table above, in which F represents the number of feet, and that should say G, or H represents the number of inches. Choose two values for X to plug into the equation to determine if the equation correctly reflects your table. So we need to go back up here to the table. We're going to write the equation for this. So I'm going to just write the equation down up here. So we made a table from the graph. Now we're going to make the equation from the graph. All right. Or we could use this table right here. 0, 0, 1, 12, 2, 24. So how you would make the equation is you'd say, all right, what is the change in y over the change in x? So you start out writing y equals mx plus b. There's two numbers that we need to figure out here. We need to figure out the m value. We need to figure out the b value. So we're going to say y equals, the m value is the change in y over the change in x. You're going up by 12 here, so that's a rise of 12. You're going up by 1 here, that's 12 over 1. So your rate of change is 12. The change in y over the change in x. The next. All right, so now, our b value, we got to figure out when x is 0, what is y? Like, where is it crossing the y-axis? Like, our graph would look like this, with this being 0, 0. That point being at 0, 0. All right? Well, we can look at the table. When x is 0, y is 0. So you could put plus 0 right here. That's not wrong. But if it was, they're not going to mark that wrong because technically it's not wrong. It's just not how we write it in math, all right? We don't order 2 large pizzas plus nothing. So we would just say the equation is y equals 12x. Now it's saying plug in, the next part of this says choose two values for x to plug into the equation to determine if the equation correctly reflects your table. So I'm going to pick the first one. We have 0, 0. When x is 0, what should y be? So I'm going to say, what is y when x is 0? What is 12 times 0? 0. It works for that one. And then if I use the next point, which is 1, I say what is y when x is 1? That would be 12 times 1, which is 12. Guys, don't pick and choose what you want to do. Or, excuse me. Let's move back here a little bit. It says write the equation in terms of f and h. Change that to x and y, okay? We'll change that to x and y. I do want you to understand that you don't necessarily have to have x and y, but in this case the tables are represented x and y, so we're not going to change it to f and h. So the next part says, the graph Trinity created, though incorrect, was still linear. How is that possible? Explain what Trinity did wrong when sketching her graph. She started at 0, 12, and it should have been 0, 0. Guys, you're going to want to write complete sentences here. I'm just, for the sake of time, I'm going kind of faster on this. All right, I'm just going to go a little bit faster. It's still linear. Like, that's the reason why her graph was wrong. That's what she did wrong. She started at 0, 12. She should have started at 0, 0. She put on the y-axis, she started at 12. The reason it's still linear is because she still went at a constant rate of change, which, you know, is going to give her a straight line. However, it's just, you know, it's still going to give you a straight line. However, it's not the correct straight line, all right? So that's, I mean, more or less you write that in sentence form, okay? All right, let's see what number 6 looks like. Which of the following proportional relationships? I have not been using that term very much this year. Proportional just, I mean, it's the same thing as a linear equation, all right? Proportional just means it's linear. It means there's a proportion between the two variables. Which has the same rate of change as the table shown below. So we got to figure out what the rate of change of the table is first. How you determine rate of change is the change in y divided by the change in x. That's what those triangles mean. All right, the change in, that means subtraction. If I say the change in temperature is 30 degrees, that means if I said the change in temperature was 50 degrees yesterday and 40 degrees today, what is the change? You'd say that it changed by 10. You subtract those two numbers. We're going to subtract the y values. From 6 to 8, you're going up by 2. So you could say 8 minus 6 divided by, if I use 8 first, that'd be 4 minus 3. That's the foolproof way of doing it. You know, you're going to take the two y values and subtract them. Or, take the two y values and subtract them. Take the two x values and subtract them. That's going to give you 2 over 1, which is 2. Or you could say there's a change, it's going up by 2 here, it's going up by 1 here. The change in y over the change in x, that's 2 over 1, which is 2. So which of the following proportional relationship has the same rate of change as that table? It's not A, because the rate of change for A is 3. It's not C, because that is the change in x over the change in y. That's going to be in there. You're going to see if you know what you're doing. This would be your best bet. I know that there's a 2 right in front of that x, but that y is not by itself. To get the y by itself, you have to divide by 2. If you do that at one side, you got to do it the other side. 2 divided by 2 would be 1. That would be y equals x. Not y equals 2x. Your answer would be D. Like, if you didn't know between B and D, I don't know about B because it's got that 2 in front of the y, but I know the slope or the rate of change for D is 2. So I know that's the answer I'm going to go with. All right. Number 7. Okay, question number 7. This is a good question. Saying 3x, it says the following equation has infinitely many solutions. So if your answer is going to be infinity, what is going to happen is at the very end, after you combine the like terms, it is going to say 0 equals 0. All right. If your answer is going to be no solution, your answer would be 0 equals some number, like let's just say 4, or just any, you know, it could be -3, it could be anything, or it could be the other way around, like the 0's on the right hand side. If your answer is a number, it's going to say x, or whatever the variable is, equals something. So the only time your answer is going to be infinite solutions or no solutions is if the variables cancel out, which they are going to cancel here. We just got to figure out what this number is. Let's call this A. We got to figure out what A is. All right, so we're just giving this a letter, okay? We're just assigning it a name. Well, what we're going to do is we're going to say 3x minus x, so we're going to do our integer room, variable room here. And when we change the side, we're going to change the sign. I'm going to leave the variables on the right or on the left. This is 3x minus x, and then 2x, change the side, change the sign. Over here we're going to have the 8, and then we're going to have minus 5. And then we've got this a we don't know what to do with. Okay, well, in order for the variables to cancel out, we have 3x minus x, which is 2x, and 2x minus 2x, which is 0. So we don't need another x term, so we know that this a is going to be an integer. Okay, we've got to make this a number that will make 8 minus 5 0. So over here, like, we're just going to leave the variables like they are. 3x minus x is 2x, and 2x minus 2x, that's 0x, there's a 0. That's good, that's what we wanted on the left-hand side. We need whatever's on the right-hand side to equal 0. So that's 8 minus 5, which is 3. The only thing that a can be would be negative 3, because 8 minus 5 is 3. 3 minus 3, we give it a 0. That would mean my answer is infinite number of solutions. So your answer there would be like a equals negative 3, or if you assigned it a different variable, you could just put the answer as negative 3, or just put a negative 3 right there in where the answer goes, okay, if you didn't draw over it like I did. Number 8, this is one you cannot afford to get wrong. We've been over and over and over and over and over this. You cannot afford to get this one wrong. We go ahead and get rid of C and D. That's the first thing I look at, is you look at the number or the sign in front of the slope. The rate of change of this equation or of this graph is positive. It is increasing. It's not C, it's not D. Go ahead and get rid of them because they have negative signs right there in front. Now it's a 50-50 shot of getting it right. It's either a rise 2, run 5, or rise 1, run 3. They're both crossing at negative 2, so the y-intercept's the same for both. What is the rate of change? Like, how do you get from one point to the next on this line? It's crossing here. You're going to rise 1, run 3. Takes 5 seconds. You can't afford to get that one wrong. All right? Moving right along. Let's look at number 9. Is negative 2 the solution to the equation 2f minus 3. All right, so there's your equation. Show your work below to either show the solution is negative 2 or is not negative 2. You're going to plug negative 2 in for f and see if the left-hand side equals 25. If the left-hand side equals the right-hand side, then negative 2 is your answer. If you get anything other than 25, negative 2 is not the answer. That's all this is. All right? You could distribute, combine like terms, solve, and see if it at the very end if it says f equals negative 2. I'm going to answer this one by just plugging negative 2 in for f, and I'm going to simplify it. You would be simplifying the left-hand side of an equation. So we're going to put in for f what we are going to assume f is. I mean, we're just kind of proving that it is or is not. So we're going to assume that it is for a second. Well, if we assume that means our assumption would be correct at the end if the left-hand side equals 25. So all I've done is the entire left-hand side. I've taken out the f's and I've put in negative 2's. So now is like PEMDAS, okay? We're going to do what's inside the parentheses first. That's 4 times negative 2 minus 5. You do multiplication first. So I'm going to just go ahead and multiply this just because we can. I mean, it's the same way. This is going to give us negative 4 minus 3. 4 times negative 2 is negative 8. Negative 8 minus 5 will give us negative 13. We're going to see if that equals 25. Now, we are going to multiply negative 3 times negative 13 because it's the order of operations. So you get negative 4 plus 39. Negative times a negative is a positive. Negative 4 plus 39 is 35. So that says 35 equals 25. And since that is not true, the answer here is no. All right, because 35 does not equal 25. When you put negative 2 in there, the left-hand side does not equal the right-hand side. All right, if you were to solve for f, you distribute, you combine like terms, and then you'd solve. Okay, that's all you need to show for that one. Show your work below to either show the solution is negative 2 or is not. I mean, that's what all this is right here. That's showing your work. and it says, is it the solution? He said, no. That's good enough. All right, move on. Choose all of the following answer choices that represent a function. So this means this is one of those questions, again, where you are going to have several of them. You can answer more than one. So there's more than, that increases your chance of getting it wrong that way. So you really got to be careful here. It says circle the ones that are not a function, I believe. Choose all of the function choices that are a function. Okay, so if it is a function, that means that every x is going to have only one y. That means that every input value is going to have only one output value. Simply put, you can't have, it will not be a function if there is a value of x that repeats and the y is different. We go through, this is what we call a relation. We're going to go through the x values to see if any of them repeat. -3, 0, 7, 2, 8. None of them are repeating, so this is our answer. I mean, that's an answer. We got to choose all of them that are answers. How you determine if a graph is a function is you use the vertical line test. You put, if there is a time in which you can put a vertical line through the coordinate plane and it crosses the graph more than once, it's not a function. So if I put a vertical line, let's say here, that crosses the graph, my graph, the red line, at one time, so you're good. However, if I put a vertical line through here, it crosses here, 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 here. This is a graph that is not a function because it's like being at two places at the same time. You have an ordered pair here of, let's just say, I'm just going to call this 3, and let's call this 3. So you have an ordered pair at 3, 0, and you have an ordered pair at 3, 3. You know, you have an x with more than one y value. So that is going to, I mean, that's not a function, so this is not one of them. All right. All you're looking for, this is what we call a mapping. In a mapping, you look to see if two lines are coming out of the same x at the same x value. All these over here are your x's. All these are over here are your y's. Domain x, range y. -1 is going with 5. 0 is going with 3. We do not have values of x repeating. There's no, if we had two lines coming out of this 0 right here, that is something that would not be a function because 0 is going with 3 and it's going with 21. It can't be going with both. But since we don't have that line right there, or a line going from one of the x values to two y values, this is a function. So a and c are both functions. A table is the same thing as a relation, which is up here. It's the same thing as a mapping. It's just a different way of presenting it. We have 5, -5, 6, -5. Well, I look here and I have a -5 and a -5. They're repeating. The x is repeating. The y value is different. Therefore, this is not a function. Okay, your answer for this one is just a and c. All right. That's all the time for this, or we'll move on to the next one here. We're going to get to number 11 next. All right. All right, this is a system of equations questions. We would probably use the substitution method because we have a variable by itself in y. So since y is by itself, we can plug what y equals, which is 6x minus 15, in for y into the other equation. And we've done this before. Now, seeing as how it's a multiple choice question, you could go through each one of these ordered pairs and plug the x in for x, plug the y in for y for both equations, and if the left-hand side equals the right-hand side, that is your answer. So I want to just show you that method first. Your first equation here is 9x plus y equals 30. I'm going to put a 3 in for x. I'm going to put a 5 in for y because this is my x value and this is my y value. So I would write it as 9 parentheses plus, and then my parentheses equals 30. And in those parentheses, I'm going to put x, which is 3. And then for y, I'm going to put 5. So basically, this is like saying 9 times 3 plus 5 equals 30. 9 times 3 is 27. And then you add 5. You can drop the parentheses because you're not distributing anything. And all of that equals 30. Guys, 27 plus 5 does not equal 30. That means that this point is not a solution to the first equation. A is not your answer. That's one way you could go about doing it. You could plug in the x for x, plug in the y for each one of these, and if it works for both equations, that's your answer. I want to show you the substitution method. Since y equals 6x minus 15, and we have a y in the other equation, we could put what y equals into the other equation, which is 6x minus 15. So we would rewrite the first equation exactly how it's written. Excuse me. But wherever we see a variable, we are going to put, or wherever we see a y, we are going to put what y equals. So this should say 9x plus, and then you're going to put your parentheses. We're going to have 6x minus 15 because that is what y equals. And all of that is 30. You got to finish writing the equation. Don't just stop once you substitute in. All right, now this is distribute, combine, like term, solve. There's nothing to distribute here, or you could think of it as like there's an imaginary 1 that you would distribute that's in front of here. Like there'd be a 1 right here. Well, 1 times 6x is 6x, and 1 times negative 15 is negative 15. It hasn't changed anything. So we're going to bring down our 9x, and 1 times 6x is positive 6x, and 1 times negative 15 is negative 15. All right, and this is where you do your boxes. All right. I'm going to keep the variables on the left. I'm going to keep the integers on the right. This would leave us with 30 plus 15. Sorry if that's hard. It's kind of small. 30 plus 15. Because this is negative 15, you change the side, you change the sign. And this is just 9x plus 6x, which gives you 15x equals 45. So x is going to equal, divide both sides by 15. 45 divided by 15 would give you 3. So my x value is 3. I don't even need to find the y value. If it's between B, C, and D, which one has an x value of 3? Your answer would be B. Now, just to check it, if I put a 3 in for x into this equation here, 6 times 3 would give me 18, and then 18 minus 15 would give me 3, which is my output value here. So that is your answer would be. That's how a couple ways you could look at that, a couple ways you could solve for that, okay? Question number 12. This is one of the best questions on here. I mean, it's probably one of the most difficult ones. I want you to understand the logic that's going on here. This looks like there's a little bit of geometry, there's a little bit of algebra, there's all kinds of stuff that goes in here. Could you use the guess and check method? Absolutely. It might just take you a while. All right, so it says a right triangle is made up of 2 acute angles, angle A and angle B. Guys, anytime you hear the words right triangle or something, you got a word problem you don't know how to do, draw a picture, all right? Like there is a right triangle. Okay, so we're going to assume this is our right triangle. All right, so what we know about a triangle is that the 3 angles have to add up together to give us 180. So when we add, like if this is 90 degrees and it says this is angle A and this is angle B, which are both acute, but it's not drawn to scale. I just happen to draw a right triangle. That means that angle A and angle B are since they're both acute and since it's a right triangle, if this is 90, angle A and B have to equal 90 when we add them together. It says the measure of angle A is 64 greater than the measure of B. So with those two statements, we're going to set up a system of equations here. All right, so how we would do this is we would say, all right, well, the 2 angles A and B, A plus B, have to add together to give us 90. Because if this angle is 90 degrees, these 2 angles have to add together to give us 90 degrees, because 90 is 180, and a triangle has 180 degrees in it. Our next equation is you would say the measure of angle A is 64 greater than the measure of angle B. So you would say A is, that means A equals B plus 64. All right, if you added 64 to B, you would have A. All right, so that's just the logic we're going through. So now, since A is by itself, we would use the substitution method here. A is equal to B plus 64. So you'd put a B plus 64 in for A. So to finish writing the equation, we just put plus B equals 90. B plus 64 plus b. So we could just drop the parentheses now. It's just b plus 64 plus b is equal to 90. You do your integer room, your variable room here. You get b plus b. Those are b's. And then 90 minus 64. Let me do the boxes last. 90 minus 64. This, of course, gives us 2b. 90 minus 64 is going to be, what, 26? Yeah? Divide both sides by 2, and you get b is equal to 13. Well, if a is 64 more than that, you'd say 64 plus 13. What does that give you? 64 plus 13 is going to give us 77. So that must mean a is 77 degrees. And now check it to see if it works. 77 plus 13, does that add together give you 90? Wait, 6, 7, 8, 9, 10, 0. 7 plus 3 is 10, so that gives you 7 plus 1, which is 8, plus 1, which is 9. So 77 plus 13 equal 90. And then A is 64 more than B. So 64 plus 13 gives you 77. So this is your correct answer. You always want to say, does my answer make sense? It's a tough question. I understand you wouldn't know where to start, but it looks like a geometry question, and you do need to know some geometry going into that question. But it's more of a system of how to set up this system of equations. Okay. Speaking of system of equations, this says choose the two systems of linear equations that have exactly one solution. That means you're going to get an answer like 3, 2. Because if you remember, the answer to a system of equations is an ordered pair. We want to know which ones get ordered pairs, and we want to know which of the ones get infinite solutions and no solutions. Those are the ones we want to cancel out. I can go ahead and tell you right now we're going to get rid of A. And how I can tell that so fast is by doing the elimination method. If I subtract these, 2x minus 2x is 0, y minus y is 0. The variables cancel out. And it's just asking us, does it have one solution? This says 0 plus 0 equals 4, which is a false statement. The answer to that's no solution. All right? The coefficients aren't the same here. The coefficients aren't the same here. If I were to subtract, or if I were to multiply, ooh, that's a tough question. We would have to multiply this second one times 2 in order to get like coefficients. So you get 6x plus 4y equals 8. We multiplied it by 2, so you get 6x plus 4y equals 8. Well, that's the same thing as the first one, so this one is also going to be infinite solutions. Did the elimination method here, you'd get something like 0 equals 0. Therefore, your answer would be infinite solutions. So that is not one of them. We want one that has one solution. All right? So it says choose the two systems of linear equations that have exactly one solution. That'd be B and D. All right? Both of those would have one solution. And if you tried it, that would work.
At this time, please.
What you're looking for your answer to be no solution or infinite solution is if the variables both cancel out. Then it's going to either be no solution or infinite solutions. Question number 14. We're going to solve this system by graphing. You have got to know how to graph in order to do well in this Milestones test. I'm telling you right now. We are going to write M equals B equals for both of these equations. The first equation, y equals 3/4 x plus 5. You know, if it's in the form y equals mx plus b, the b value is the number that's out here by itself, so we would say it's 5, and since it's a positive, we just leave it like 5. And then your m value, which is the steepness, it's the slope, it's how steep it's going to be. The rate of change, it's 3/4. So to graph this thing, we're going to start up here at 5. 1, 2, 3, 4, 5. We're going to put a point right there on the y-axis at 5. It's crazy is like, this involves no math. You know what I mean? Like, you're not asked to add, subtract, multiply, or divide anything. We still have a hard time with this. Now, we are going to go up 3 over 4. But if you go up 3 over 4, you're off your graph. So let's go down 3. 1, 2, 3. And to the left 4. 1, 2, 3, 4. 4. Yeah, that's where we're stopping. And that's going to give you a positive slope. Down 3. 1, 2, 3. 1, 2, 3. So that's going to be off our graph also. So this is the equation, or this is the line for that first equation. All right, it's crossing the y-axis at 5. It's got a slope of 3. It's got a rise of 3, run of 4. This case, since it went off our graph, we went down 3. 1, 2, 3, and then to the left 4. 1, 2, 3, 4. And 2 negatives would make it positive. All right, so the second one is y equals 1/2 x plus 4. We are going to start, I'm going to use a different color here. You're going to start at positive 4. So the b value is 4. Why didn't you change colors? There we go. 4. And the m value is going to be 1/2. So you're going to start at 4 on the y-axis. So that point is going to be 1, 2, 3, 4. The rate of change is going to be 1/2. So you could go up 1 over 2, up 1 over 2, or you could go down 1 to the left 2, 1, 2, down 1 to the left 2, and that's where they're crossing right there at that big point right there. Right there, yeah. So it's going to look like this. Now the graph is beautiful. I like it. That's not your answer. It says, using the coordinate plane below to solve the system of equations. Guys, that's just the graph. The solution is going to be an ordered pair, or infinite solution or no solutions, but that's neither one of those. Those lines are crossing here at negative 1, 2, 3, 4. And then you go up 2. Please don't miss this question because you don't know how to plot a point in the coordinate plane. You're going to go to the left 4, and then you're going to go up 2, yeah? All right, we got some time to do some more, definitely. Number 15, which statement is true regarding the two equations shown below? Oh my goodness gracious. I know how to solve multi-step equations, but I've never seen one with a fraction like this. Look, you're going to have a calculator, okay? And if you don't have a calculator, there's only 10 questions that you can't use it on. You'll still be fine. Type 1/3 times 9 into the calculator. 1 divided by 3 times 9. 1/3 times 9 is the same thing as dividing by 3. We're taking 9 and dividing by 3. So 1/3 times 9 would be 3. So 1/3 times 9g would be 3g. And then we're going to do 1/3 times negative 15. Like, it would be a nightmare if it was 2 halves. Or, I'm sorry, not 2 halves. If it was like 1/2. Because you'd get fractions right here, and then you'd have to add and subtract with fractions, and it's just, you know, is it possible? Absolutely. But it's just a pain in the tail. How did I get negative 5 right there? I multiply 1/3 times negative 15. Basically, you get negative 15 divided by 3. So this is what our equation looks like. We're going to write our equal sign. We have a negative 4g on the right-hand side. So let's put it on the left-hand side. This is going to be 3g plus 4g. I know it's kind of hard to see, but that's 7g equals. This is going to be 9 plus 5, which gives you 14. So our g value is 2. Our value for g is 2. Well, we got to compare that to the equation over here. We're going to go straight in the boxes. Nothing to distribute here. I'm going to start drawing the boxes first and then put the numbers in there. Okay, we've got an 4h on this side. We're going to leave it as a 4h. We got an 8h over here. We're going to leave it as an 8h. And then this 3, you're going to change the side. You're going to change the sign. It's going to become minus 3h. Now in our integer room, we have a 7 and a negative 11. We did not change the side, so we're going to leave the sign the same. And then on the right-hand side, we have minus 13. It's going to become plus 13. 7 minus 11. Let's rewrite this sentence. Let's say 13 plus 7 minus 11. Or you could just do it like this. What's 7 minus 11? That gives you negative 4. And negative 4 plus 13. Whew. That's going to give you 9. So you would get 9 is equal to 4h plus 8h is 12h. 12 minus 3 would give me 9. So you get 9h. So you get 9 equals 9h. And which number times 9 gives you 9? Would be 1. So your g value is 2, your h value is 1. Well, we got to pick which one of these is the best answer here. All right? So let's do this. Oh, come on. So remember, we had g, which was 1, or I'm sorry, g, which is 2, and then h, which is 1. So we're going to figure out which one of these is the best answer here. All right. Ooh, quickly. Okay, so we determined that g is 2, and we did that by solving for g. It's a multi-step equation, and we determined that h was 1. So since g is greater than 1, your answer here is obviously going to be b, because that little sign right there means greater than. So g is greater than 1. Okay? Moving on to the next question. We're going down here to 16. It says the type of graph below represents a proportional relationship between x and y. It just means it's a linear relationship. There is a proportion. There's a relationship between those two things, or between the two variables here, whatever they may be in this graph. Which equation represents proportional relationships with a rate of change greater than the rate of change that's in the graph? So we're looking for, of all of the answers down here, which one has a greater rate of change than that of the graph? So the first thing that we need to do is we are going to figure out what the rate of change from the graph is. We're going to do that by using rise over run. We're going to start at one point and go to another point. Well, if you don't have points on the line, you got to put them there. You look at where the line is crossing both an x and a y axis. It's crossing an x and y at 0, 0, and as you continue to go, it's not crossing another one until right here. The order pair 3, 2. Now, how you get steepness of a line, how you get slope, is you're going to use rise over run, not run over rise. All right, you're going to rise 2 and run 3. So the rate of change is 2/3, and we always want to leave it as a fraction. But to help us out here a little bit, to make sure that we know exactly what number is greater than 2/3, what's less than 2/3, it's easier for us to conceptualize a decimal, which would be 2/3 is 2 divided by 3, which would be 0.6666 repeating. All right, so we're looking for any number that has a slope or a rate of change greater than 0.666 or 2/3. Well, let's look at A. What's the rate of change for A? I mean, there's only one number there. There's a 3 right here. The rate of change is the number that's being multiplied by the x. All right, sometimes they could be rearranged a little bit. It's hard to tell. You don't just pick the number that's in front. You pick the number that's being multiplied by x. That's your rate of change. And 3 is obviously bigger than 2/3. C, 0.5, not bigger than 0.6. Answer's not C. E is the same thing as C. 1/2 is the same thing as 0.5. Now we have 2/3. It does not say select all of the answers or all of the equations that have greater than or equal to the rate of change of the graph. It says greater than, and this is y equals 2/3 x. That's what this equation is. It's not greater than it. This is not your answer. It is that equation. All right, this line right here is y equals 2/3 x. You know, plus 0, but you don't need the 0. The next one, y equals 1 and 1/2 x. 1 and 1/2 is 1.5. It's going to be D, and also it's going to be F, because 2 is also greater than it. So it takes a little bit of time. You think that it's going to be harder than it is. All right. Okay, 17, same thing. It looks like a hard problem. It's really not once you break it apart and just kind of understand what the question is asking you. It says Neil is determining the equation given to him in a graph. So he's given a graph. He's got to determine the equation. He notices that the graph is linear, crosses through the points -5, 3 and 5, 4. So if we did just a quick sketch here, -5, 3 is here, +5, 4 is here. So we know it's going to be increasing, so it's got to be positive, right? All right, Neil's answer of 1/10 is the value for the slope of the equation he calculated. So he got a positive answer. That's good. Which of the following choices is the best? So the first answer choice says that he got it right, and the other 3 answer choices say that he got it incorrect, and it gives you reasons why they're incorrect. It says, you know, the slope of the line should have been calculated to get -10. That's what B says. C says, the slope of the line is indeterminate since it's a vertical line. Well, it's not a vertical line. We just did a quick little sketch right here. I know it's not C. Go ahead and get rid of that. We can do that. And then D, it says the value of 1/10 is incorrect because the slope of the line Neil should have calculated is 10. So let's just go through these. Let's figure out how to determine the rate of change given a two ordered pairs. If we were going to make that into a table, your first ordered pair is -5, 3, and your next ordered pair would be 5, 4. So to go from 3 to 4, you're rising up one time. To go from -5 to 5, you are going from -5 to 0, which is 5 times, and then from 0 to 5, which is another 5 times. That gives you a total of 10. And are you going up or down? You're going up. So your rate of change, or your how it's changing in the x's, is going to be by 10. So here's the $1,000,000 question. Is our answer A or is it D? Do we do the change in y over the change in x? Is it 1/10 or is it 10/1? You better know that by now. If you don't, you better figure it out. This is not right. He got it right to begin with. It's 1/10. It's the change in y divided by the change in x. All right? It's definitely not B. It says that it should be -10. We already know that line's not going down, it's going up. So you could get rid of B and C pretty quick. You just got to know if it's going, if it's the change in y over the change in x. That's what that question is asking of you. All right. Number 18. Determine which of the following proportional relationships has the greatest rate of change. Let x represent the number of casts and y represent the number of fish caught. So if you're not familiar with that term, casts, that's when you chuck your bait out in the water to go catch a fish. All right, that's called a cast. So he's casting his bait out into the water, and there's a relationship between every time he casts it out there and the number of fish he's catching. A, it says Andrew is going fishing for largemouth bass over spring break. For every 25 times he casts out the bait, he catches 4 fish. So we got to figure out what the rate of change is here. For every 25 times he casts out the bait, he catches 4 fish. Well, you could look at that as, it's going to be a proportion. Is it going to be 25 over 4 or 4 out of 25? Well, I mean, what makes the most sense? If it was 25 out of 4, that is a number close to 5. That means every time he casts out his bait, he catches 5 fish. That makes not one bit of sense. The rate of change here is 4 over 25. Every 4 times he makes a cast, or every 25 times he makes a cast, he catches 4 fish. Does that seem about right? Like, does that seem like it makes sense? Like 4 out of 25? I mean, if your answer is like a number greater than 1, obviously you can't catch more than 1 fish when you throw out your, so just look at it that way. Every 25 times he makes a cast, he catches 4 fish. That's actually pretty good. So that is a number, that is a number close to 1/5. All right, we'll see what that gives. Because I know 5 out of 25 is 1 over 5, which is 0.2. So this is a number close to 0.2. So I'm going to approximate this is a little under 0.2. I'm going to say it's about like 1 point. I don't know off the top of my head. I don't need to. Like, in case you didn't have a calculator here, you could just approximate it. You could say it's about 0.18, something like that. I'm just going to say 0.18. This is 3/4. The rate of change is 3 over 4, so that would give us a rate of change of 0.75 if we wanted to kind of conceptualize it a little bit. So it would be 0.35, or 0.75, excuse me. So far, this one has the greater rate of change. It's already bigger than A, so A is definitely not our answer. We can get rid of it. All right? So that has a rate of change of 0.18. This one has a rate of change of 0.75, so A is not your answer. If we were to look at C, so we got to get rid of this. If we were to look at C, we're going to do the change in y over the change in x. You're going up by 2 every time. So the change in y is 2. The change in x, you're going up by 20 every time. 20 over 2 would be 10. 2 over 20 is 1 over 10. Or you've got to know that it's the change in y over the change in x. Your rate of change for this one would be 1/10. That would be 0.1. All right. So 0.1 is definitely less than 0.75. I know C is not my answer. So far, 0.7 has got it. So far, 0.7 is the greater rate of change. Because 0.75 is bigger than 0.1, it's also bigger than 0.18. D, let's see how we go here. You're going to start at this point. You're going to rise up, and you're going to run. I see we're going up 1 over 2, up 1 over 2, up 1 over 2. The rise over run is 1/2. That would give you 0.5, and obviously 0.5 is less than 0.75, so your answer is going to be B. All right? Good. Let's go on to number 19. All right, number 19 says circle the answer choice that best represents a linear relationship. So if you remember correctly with equations, you're looking for exponents and square roots. So like x squared, square root of x, and that can be y, and it can be x, okay? You're looking for variables touching each other because that's basically exponents, or it could be x and a y. The reason why that is that would be nonlinear is because if you try to get the x by itself, you would have x in the bottom of a fraction, which also is a no-no for to be linear. Okay, so you're looking for exponents, square roots, variables in the bottom of the fraction, and you're looking for variables to be touching each other. All right. So we look at A. It's got a square root sign. You can go ahead and get rid of it. You can look at B. It's not a straight line. It's not linear. Okay. C, 3xy equals -5. You have variables touching each other. That is going to be nonlinear. Now, when it gets to a table, that's where just a little bit of work comes in, or a little bit of computation, rather. Before, we just looked at them. It requires memorization. Well, we got to know that a table, in order for it to be linear, has to have a constant rate of change, and it's got to be constant throughout the entire graph, or the entire table, rather. All right? Like, of course, any two-ordered pairs are going to have a rate of change, but not every 3 pairs is going to. So we're going from the change in y, that's -31 to -17. You are going up by 14. All right, from -17 to -3, again, you're going up by 14. And then from -3 to -11, you're going up by 14. So the change in y is consistent, it's constant throughout the whole thing. You're going up by 14 each time. $14. All right, now let's look at our change in x. From 18 to 13, you're actually going down. You're going down by 5. From 13 to 8, you are going down by 5. And then from 8 to 3, you're going down by 5. Since we have the same numbers on both sides, or it doesn't have to be like that. What does have to happen is when you simplify the fraction, it's got to give you the same thing. 14 over -5 is the same thing as 14 over -5, which is the same thing as 14 over -5. This is going to be a linear relationship. D is. All right, because it has a constant rate of change. E, I put that on there on purpose, definitely. Does it have any square roots? Does it have any exponents? Does it have variables touching each other? Does it have variables in the bottom of a fraction? Does it have absolute value, logarithms, natural log, any of that? No. Since it doesn't have any of that, you're going to treat it as a linear equation. Sorry, I marked it out. This is one of our answers. So far, our answers are D and E. This is linear because it doesn't have any of that stuff up there that we memorized. All right? So F, it does have something up there. It has a variable in the bottom of a fraction. That's going to be nonlinear. G, we're looking for a constant rate of change. 25 to 36, you're going up by 9. 36 to 49. I'm sorry, you're going up by 11 right here. Sorry. 25 to 36, you're going up by 11. 36 to 49, you're going up by 13. And then 49 to 64, you're going up by 15. There is a pattern there in the y's, 11, 13, 15. I bet you I could figure out what the next one would be. I bet you the change would be 17. You add 17 to 64, you're going to get your next answer, which is 81. Well, let's look at our x's. Our x's are going from -5 to -6. That is going down by 1.
negative 6 to negative 7, that's going down by 1. Negative 7, negative 8, that's going down by 1. So there's a constant rate of change there. So let's look at our change in y over change in x. So far we've got 11 over negative 1, and then we have 13 over negative 1, and then we have 15 over negative 1. If I simplify 11 over negative 1, I get negative 11. And if I simplify 13 over negative 1, I get negative 13. That does not have a constant rate of change. It's not going by the same amount. We're taking this number right here and we're squaring it, and we're getting 25. Negative 5 times negative 5 gives you 25. Negative 6 times negative 6 is 36. And if you have an equation in which a number is being squared, that is not a linear relationship. H is not going to be linear either because it has two variables touching each other. Just because you have a word problem doesn't mean it's too hard for you to do. I can't tell you how many times little kids raise their hand. I don't understand this one. And it's like, did you read it? Like, if you read it, you'd understand it. It's shocking. If you read this question, you would know exactly what it's asking you. All right? I mean, all three of these part A, part B, and part C are asking you the same thing. It says in Millie's math textbook, there are several geometric formulas that she needed to study for her milestone exam. Basically meaning she just got three formulas, or she's got, what does that say, three? There are several, all right? The first formula she needed to know was the formula for surface area of a rectangular prism. That's like a shoebox. The surface area can be written as 2 times the quantity width times, or WL plus HL plus HW, in which W is the width, L is the length, and H stands for the height. So we're going to take that into consideration here. All right. The next three formulas she needed to know are cylinder, which we've talked about this year, pi r squared times the height, and then a cone, which is 1/3 pi r squared times the height, and then the volume of a sphere, which is 4/3 pi r cubed, where in each formula H stands for the height and R stands for the radius. Of the formulas listed, Millie noticed that one of the formulas could be linear while the other three are non-linear. Okay, what this means is that three of the formulas, if you were to graph them with the same, like with consistent numbers, like if you put a 1 in, you put a 2 in, and then you put a 3 in, it would not be going in a straight line. All right. The one that would be going in a straight line if you went consistently with your integers would be the surface area of the rectangular prism. I'm just shortening it because I like those initials. All right. How do we know that the other three are going to be nonlinear? How are these three different from the surface area one? Well, they all got exponents. You'd say x, nets. That's all you need to put. I mean, you'd probably want to write down in more sentences, or in a couple sentences, but you'd say anytime you have an exponent, you're either getting really big really fast, or you're getting really small really fast. It's not going to create a straight line. All right? Now, C says, explain what makes the three nonlinear equations different from the linear equation. How would you test to see if they are linear or nonlinear? The second part of this question is what you're going to be answering. How would you test to see if they are linear or nonlinear? Well, you could graph them, or you could put a value in for each. You could put a number in for each variable, and you could make them consecutive. So, like for cylinder, try putting a 1 in for R and a 2 in for H. And then try putting a 2 in for R and a 3 in for H. I mean, it would be going up by the same amount every time if it was linear, all right? That wouldn't be. I'm not going to do the math. That's for you to, y'all know how to do that. Just plug in 1 for R, plug in 2 for H, and see what you get. And then plug in, the next one, what you would do is you'd plug in 2 for R, and then 3 for H. So you're going up, you're going in a constant rate, but you're not going to get a constant output. Okay, that's all that question's asking you. Y'all know how to do that? All right, I need to scroll down here. Good. Question 21. Which equation is the same as 3x plus 3y equals negative 12, written in slope-intercept form. Oh yeah, we've got to get the y by itself. Whenever it says slope-intercept form, you're going to get the y by itself. So we are going to take, this is the y, here's the y right here. And what you need to be asking yourself is, okay, my goal is I want it to look like this. Y equals mx plus b. So we know we're trying to get the y by itself. That's your main goal. It's kind of like in order to do that, we're going to do the order of operations, but we're going to go backwards. It's like we're multiplying by 3 and we're adding 3x. Well, we want to get what's rid of furthest away from y. We want to put it on the other side. All right, it's like we do addition and subtraction first, then do multiplication and division. PEMDAS is when you're simplifying an expression. Solving equations, you want to go kind of backwards. So how do I get a 3x on the other side? We do the opposite of 3x, and we are going to subtract 3x from both sides. 3x minus 3x is 0. So over here on the right-hand side, make sure you put your equal sign down. You have minus 3x. What you do to one side, you do to the other side. Now here's the kicker. This is where kids go wrong all the time. You cannot combine these two terms, negative 12 and negative 3x. You cannot do that. We've been writing linear equations all year long, like y equals 5x plus 2. Not once have we ever said, oh, that's y equals 7x. You can't combine them together. The same way you can't combine these together. So we're going to keep them separate, and we're going to put the x term in the front because we want the b or the m term to be in the front with the x, and we want the b value to be in the back. So I'm going to write it back over here. Now we have 3y equals negative 3x because we changed the side, we changed the sign, and then minus 12. That's going to stay minus 12. So we just put the negative, like all we did is we took this 3x that was right here and we put it on the other side and made it negative. Now the other step that seems to confuse little children is if we divide this side by 3 to get rid of multiplication, or to get rid of multiplication, we're going to do the opposite, which is division, but we have to divide this entire side by 3. The entire thing we got to divide by 3. So you would get the y by itself. 3's cancel out, and you get negative 3x divided by 3. Negative divided by positive is a negative, so you get negative 1x. And let's stop there. I need to see this. I can stop right there. I know my answer is A because that's the only answer I could get. Negative 12 divided by 3, of course, gives you negative 4, so yeah, A is your answer, but we could have stopped right there because we know that the number in front of this negative x right here is a 1. All right, you move the x term to the other side and put it in front of the other one, to put it right next to the equal sign. There is an end in sight. We're on number 23, not too far away. All right, we're looking at this graph here. We're talking about minutes. We're talking about the points the Georgia Bulldogs scored. Oh yeah. Go Dogs. It says the graph is not a function, or we're picking out which one best answer in regards to the graph below. So which one of these is the best answer? It says the graph is not a function because there are two ordered pairs with the same y value with different x values. It says 14, 20, and then 23, 20. So like there. So we need to ask ourselves, does that make it not a function? If we're not sure, let's just we'll put a little tack in that. We'll come back to that later. B says the graph is only displayed in the first quadrant because the data in quadrants 2, 3, and 4 are too large to fit on a normal coordinate plane. That doesn't make one bit of sense because anything over in quadrant 2, 3, or 4 is going to be either negative time or negative points. And you can't have negative points and you can't have negative time. So I know it's not B. C, the Bulldogs did not score any points within the 14th minute. So come down here to minutes, and we're going from right here. That's about 14. Until the 33rd minute, which is right about here. So from here to here, looks like they scored some points to me. This says they didn't. C's gone. D says the graph is non-linear because the relationship between time and point scored is not a proportional relationship. It's non-linear because they don't score the same amount of points every single minute. It's not like they score 3 points a minute. It's like they might score 7, and then a few minutes later they might score 14. So it doesn't go at a constant rate. There is a relationship there. It's non-linear. I mean, there's a relationship between the minutes played and the points scored because, Georgia's always going to score those points. But, it's not going to be a constant rate of change. All right, that's how you go through that question. That's how the logic we're using. All right. Number 24. I wouldn't be surprised to see this. This is an 8th grade concept. It says your house is infested with roaches and you are in need to hire a pest control company to eradicate the insects from your property. The first company you call for a price quote is Victor's Varmint Control, which charges $50 to become a member and then $36 for each visit. All right, so Victor's Varmint Control is $50 to become a member and then $36 every time he comes over. Parker's Pest Removal is more expensive per visit at $44, but their membership cost is only $10. The third and final company you called went out of business since the amount of money being made by the company was less than the amount of the money the company spent on pest removal chemicals. You don't even need that last sentence. Like, that's just in there to throw you off. I put that in there on purpose. You might see some stuff in there that's just there that's like filler. Like, I don't even need that. Now, I'm not going to scratch it out, but I don't need that last sentence in there. I just want you to be aware of that. Part A says set up an equation for each company where X is the number of visits, Y represents how much money you would pay for each company. So we're going to set up an equation like Y equals MX plus B. Every time you are writing an equation, write that first. Now, the M value is the rate of change. We're going to do, this is Victor. All right. I'm putting a V for Victor, and I'm putting a P for Parker. Victor's Varmint Control is $50 to become a member and then $36 each visit. The M value is going to be the thing that's happening over and over and over and over again. The B value just happens one time. It's where we start from. When we call Victor, we start paying him $50. So that is the B value. And then every single time he comes out after that, it's $36. So it would be Y equals 36X plus 50. $50 and then $36 every visit. If it was, there's only two numbers there. There's only two places to put the numbers. You could get it wrong. You could have said 50x plus 36. That would mean it's $50 every visit and $36 up front. So for Parker's, the M value, what's happening over and over and over again, is 44. Now they're out of order this time, but it's what is per visit. Per visit. Every time he comes over, you pay $44. That's the thing that's happening over and over again. The thing where you start from, that's a 4. Wherever you start from, that's 10. Because that's where you begin with. That's how much money you began paying him. You started off with $10. Now, both companies tell you that you will need at least 6 visits to completely kill all of the cockroaches and their eggs. How much money would you save if you went with a cheaper company and schedule 6 visits? So we're going to see how much money it would be cheaper if we went with either company. We want to see which one's the cheapest, and we want to know by how much is it cheaper. So if one company is 50, the other company is 40, you'd say, okay, this company is cheaper, and it's cheaper by $10. This would be the better company to go with at 6 visits. So we're going to, up here in the question, it says, let X represent the number of visits. And it's telling us the number of visits is 6. So we're going to put 6 in for X. We're going to say Y equals 36 times 6 plus 50. All right. Now I believe that's 216. Let's see. 6 times 6, 18, 19, 20, 21. Yeah, 216 plus 50. And 216 plus 50 would give you $266. So what does that mean? With Victor's Varmint Control, you pay $266. Now let's talk about Parker. For 6 visits, you're going to say $44 every visit, but you only had to pay $10 up front, so you're going to add 10 to that. So we're going to say 44 times 6 plus 10 6 times 4 is 24 plus 2, 25, 26. I got 264. Is that what you got? Yeah. And then we're going to add 10 to that. Get $274. So which one's the better company? Obviously Victor is. Yeah? By how much? The question's saying how much cheaper? How much cheaper? 274 minus 266. All right. I believe that comes out to be about, $8? So your answer for this one, how much cheaper is it? Is $8 cheaper. All right. Yeah. Okay. So part C says, in order to get the best deal possible, determine how many visits it would take for the cost of the companies to be the same. I've said it over and over and over again, the key word here. I'm going to circle it 50 times. Same. What does same mean? In math, like if I said your money is the same as mine, what symbol would you put in there? Same is equals. So we want to set both companies equal to one another. And what are we trying to figure out? At how many visits? How many visits? Visits is our x. We've already said that. 6 visits, so we put 6 in for x. Up here it says let x represent the amount of visits. Well, if we're trying to solve for visits, we're trying to solve for x. We're going to put both equations in there. Well, more likely you're going to put the expressions in there. 36x plus 50. At when will that equal the same as Parker's? 44x plus 10. So we want to now solve for x because that's going to tell us how many meetings the cost would be the same. So we're going to do our boxes here. You want to write down the equal sign first. I'm going to put the x's on the right because the bigger number for the x's is on the right, and you're not going to get a negative answer here. You're going to change side, change sign. This is going to be 50 minus 10. That's going to give us 40. 36 minus 44. What is that? 8x. 8x. Sorry, I'm losing my voice a little bit. Which number times 8 gives you 40? X equals 5. What does that mean? That means, and you write this underneath there to impress all the little people that are grading this, they'd say, at 5 visits, the cost for both companies would be the same amount of money. And if you plug 5 in there, you'd be able to see exactly how much money that is. We're going to move on to the next question, all right? I mean, this just asks us at how many hours or how many visits would the cost be the same? It'd be the same at 5, all right? 25 is one of those lovely constructed response questions that we all love so much. It says Barney solved the multi-step equation below and determined the equation did not have a solution. Right here, he said no solution. We're going to determine if that was right or wrong. It says, it's telling us that's wrong. It says, what did Barney do wrong? Barney solved the multi-step equation below and determined the equation did not have a solution. What did Barney do wrong? So it's telling you he did something wrong. So we got to figure out what he did wrong. So one method you could do here, or one way you could go about answering this, is you could write the equation down and just solve it like you'd always would, and then see what step he did. I mean, what he did wrong. I mean, I think that's what they're asking you to do here. We can look, what did Barney do wrong? So, we've got to get rid of the parentheses first. We've got to get rid of the parentheses. We're going to do the boxes, and then we're going to solve. -4 is not touching the parentheses. He just brought it down. That's good so far. -2 times x is -2x. He got that. And then -2 times -4. Negative times a negative is a positive. -2 times -4 gives you +8. So the left-hand side looks good so far. The right-hand side, we're going to just bring it down. All we did is just get rid of the parentheses first. So we brought down 4 minus 5x. Now, the next step, we're going to do the boxes. And this is where you're going to go wrong if you miss one of these questions, is changing sides, change signs. I don't know, for whatever reason, kids miss that. Barney decided to put the variables on the left. Good for you, Barney. He put -2x right down in there in that box. He did not change the side, so he didn't change the sign. -2x is right there. Then this negative 5x is on the right. It is changing sides. So you're going to move it to the left-hand side, and you're going to make it positive. So it's going to be plus 5x. He's doing good so far. I'm proud of you, Barney. Now, over here, we have a 4. He put it right down in here. Over here, we have a negative 4. He made it positive 4. And over here, we have a positive 8. When he changed the side, It's going to be minus 8. So far, I'm liking what Barney did. Negative 2x plus 5x. If you don't know it, use your calculator. It ain't 7x. You're going to put 3x. It's the same thing as 5 minus 2. Negative 2 plus 5 is the same thing as 5 minus 2. So he got 3x, which is good. And then 4 plus 4 is 8. 8 minus 8 is 0. So far, I mean, we're good. All the way until we get down to our answer here. It says 3x equals 0. What did Barney do wrong? If you divide by 3 and you divide by 3, punch it in your calculator. I mean, if you don't know that already, what is 0 divided by 3? Which number times 3 would give you 0? Your answer to this is 0. It's not no solution. There is a big difference between no solution. No solution means no number would work in the whole world. And 0 means that there is a number that works. It is the number 0. So what did he do wrong? Is he said nothing times 3 would give you 0. That's a false statement. All right. 0 times 3 would give you 0. At which step did Barney make a mistake? He made a mistake right here. We already pointed an arrow to it. All right. Let's see what the next one says. What is the correct answer? The correct answer is right here, my friends. Is x equals 0. All right. Let's see what else is asking us here. Oh. Come on, Barney. Check your work to prove, what is the correct answer? Check your work to prove your answer is correct. Okay, so how we check our work is we're going to put a 0 in here for x, and we're going to put a 0 in here for x, and we're going to see if the left-hand side equals the right-hand side. So we're going to put a 0 here and a 0 here. All right, the right-hand side looks like it's going to be a lot easier. What's negative 5 times 0? It's 0. So the right-hand side is just going to be 4. We got to make sure that the left-hand side stays 4. You get 0 minus 4. You're going to do what's inside the parentheses first. You would get negative 4. And then you're doing 2 times negative 4. So I'm going to write this down. It's negative 4 minus 2 times 0 minus 4. We put a 0 in for x. So that would give us negative 4 minus 2 times negative 4. That would be negative 4. Negative 2 times negative 4 would give us positive 8. So that would be negative 4 times 8. Or negative 4 plus 8, excuse me. We can get rid of the parentheses now. Plus 8. And that would give us 4. So the left-hand side would equal the right-hand side. That's what you would put right there for B. You plug 0, you plug your answer in for the variables and see if the left-hand side equals the right-hand side. That's what you're going to do there. All right. This one... This is the last question, I believe. Yeah, this is the last one. And I don't know. When I came up with it, I thought it was pretty clever, but I don't know. I think you could make an argument. It's a couple choices here. And I'm going to show you the logic that I was using. Y'all tell me if I'm wrong. What do you think the answer is to this one? I mean, I want to hear from you. I mean, I know which one it's not. I mean, I can narrow it down to the ones that I know is not the correct answer. Since I know that, I'm going to just go through here. I'm going to show you why. Negative 7, negative 36. Negative 7, negative 36. That point would be down here. Is that anywhere on this line right here? I mean, that makes absolutely not one bit of sense. You get rid of that one. All right, look at C. It says 0, 25. Well, we don't have any numbers written here, so that could possibly be 25. And then it says 120. So this, oh boy, 120. So if this is 25, this would be 20. 15, 10, 5, 0 would be right there. So this is definitely not going by fives. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 lines right there. So it's either got to be some sort of multiple of 9 or it's got to be 9 itself. We're just picking which one of these is would be the closest. All right. So here would be 0, 25 would be right here. Like that's got to be 0, 25 because it's the y-intercept. Now 120 maybe this is 1 right here. And then this is 20. So this is 25. So it's 25, and then 1, 2, and then 20, and then 1, 2, and then this would be 15. And then 1, 2, and then it would be 10. Yeah, so that would even still give us 0 right there. This can't be it. All right? That one's going, the rate of change is not going the same amount. Okay? The rate of change there is 5. Or what is it? -5, rather. All right? So it's between B and D. It says there are 10,000 fire ants in a mound until you stepped in it. 450 angry ants flee the pile every second. Let X represent the time in seconds. So these are seconds down here. So let's get rid of this stuff. These are seconds down here. And every second, 450 of those little buggers come running out of there, ready to bite you. So this would represent there are 10,000 ant piles. So they're chilling in the nest, like they're not hurting anybody. And all of a sudden you come and step on their nest. And every second, 450 of them leave. So if this was 10,000 and we were going by 500s, we could say that this is 9,500 or 9,500, and then this would be like 9,000. All right. So if you went down 450, which would be like, this is 9,500. Just do 10,000 minus 450. You'd be about right there, right before 9,500. All right? Because you're only 50 away. You go over 1. Well, maybe, then you go down another 450 and then over 1. So I don't know about that one. Let's come back to it. Let's look at D. Is it -3/5? Well, here you're starting at some number and you go down 1, 2, 3, 1, 2, 3, 4, 5. Oh, this must be our answer, yeah? The reason this is not our answer is because of the y-intercept. It's starting up here at some sort of number. If it was y equals -3/5 x plus like 10, yeah, that would be good. That would be fine. However, that's not what it says. It says y equals -3/5 x. So what I was like, the reason that I wanted you to see this definitely is because sometimes you got to narrow it down to the 2 best choices and then go with the one that you know right and you know that is not wrong. I mean, you know that it's going to be right. Okay, you know that at least it's